Hello there and welcome to today's class. In today's class, we'll be solving over 10 most repeated post-UTME questions on chemistry. The first question we have for today says, which of the following is a mixture? Option A, sodium chloride. Option B, distilled water. Option C, air. And option D, carbon dioxide. The question says, which of the following is a mixture? The first thing we need to do here is to know the meaning of the word mixture. Now, a mixture is made up of two or more substances physically combined together. That is what a mixture simply means. A mixture is made up of two or more substances physically combined together, not chemically combined together. Now, from the options here, we have sodium chloride, which is NaCl. We have distilled water, we have air, and we have carbon dioxide. Carbon dioxide here is a pure substance. Air is not a pure substance. Air is a mixture. Air is a mixture. Air is a homogeneous mixture of nitrogen, oxygen, carbon dioxide, and water vapor. These are the constituents of air. These are what the substances that makes up air. We have distilled water. Distilled water here is a pure substance. The same with sodium chloride. It is a pure substance. The correct option here is what? Option A, air. Air is a mixture of more than one substance physically combined together. So you have nitrogen, oxygen, carbon dioxide, and water vapor. These substances combine together to form air. So the correct option here is what? Option C, air is a mixture. Now, question 2 says, which method is best for separating a mixture of sand and salt? Which method is best for separating a mixture of sand and salt? Option A, filtration and evaporation. B, sublimation. C, decantation. And D, distillation. Now, for this particular question, you have to brainstorm yourself. They said, which method is best for separating a mixture of sand and salt? Now, you assume, let's say, this is a jar of sand and salt. The first step is to add water to this mixture. If you add water to this mixture, let's assume this is a jar of water. We add water. We add water to this mixture. Now, the water we added to this mixture is going to dissolve the salt in this water. Don't forget, sand is insoluble. Sand will not dissolve. The only thing that will dissolve in this mixture is the salt. We filter it off. It's going to give us something like this. And then we have something like this. This becomes the mixture of the sand, of the salt and water. This is the sand at the bottom. Now we'll filter this stuff up. We'll filter this one outside. When we filter it, we'll have We just have the fluid. We have the water outside, a mixture of what? Water and salt. That's what we have here. This is water and salt. This is what? This is water, salt, and sand. This is just what? Sand and salt. Why this is what? This is the water. Now when you get to this point, you have just water and salt left in this jar. The sand will be left here. So what will be left here is what? Just the sand. Now we have separated the salt and the water. We have the sand here. When we are done with that, we'll heat this up to evaporate the water. The water goes out. If you heat it up, let's assume this is heat. Let's assume this is heat. If we heat this stuff up, it's going to evaporate, leaving only what? The salt and the sand. So the correct option here is option A, filtration and what? Evaporation. That is the correct answer. Filtration and what? Evaporation. Don't forget, first you add water to the mixture. After that, you separate the salt, water and sand. You separate it, you remove the water, the salt and the water to another jar. Then you evaporate it. The correct option here is what? Filtration and evaporation. Not sublimation, not decantation, not distillation. So this is our correct answer. Question 3 says, what is the pH of a neutral solution at 25 degrees Celsius? What is the pH of a neutral solution at 25 degrees Celsius? Option A, 0. Option B, 7. Option C, 14. And option D, 1. Now, at 25 degrees Celsius, which is room temperature, a neutral solution such as a pure water has a pH of 7. A neutral solution such as pure water has a pH of 7. Now anything less than 7 is acidic. pH less than 7 is acidic. pH greater than 7 is basic, also known as alkaline. Some of you might be asking, what does pH mean, or what is the pH? pH is a logarithmic scale used in measuring the concentration of hydrogen ion. That is what the pH means. The question says, what is the pH of a neutral solution? Don't forget, a neutral solution such as pure water has a pH of what? 7. So we have 7 here. The pH scale, don't forget, ranges from 1 to what? 14. So we have here to be, let's say, 7, 8, 9, 10, 11, 12, 13, and 14. Here we have 6, 5, 4, 3, 2, 1, 0. Now, from here to here, this is acidic. From here to here, this is what? Basic. Now, anything within this range is neutral. At 0.7 here is neutral. So the correct option here remains option B, 7. Question 4 says, which of the following gases can be collected over water because it is insoluble? Which of the following gases can be collected over water because it is insoluble? Option A, we have hydrogen chloride. Option B, we have ammonia. Option C, we have oxygen. And option D, we have sulfur dioxide. To collect gases over water, To collect gases over water, they must be insoluble or slightly soluble. They must be insoluble or slightly soluble. For this now, we have hydrogen chloride, HCl, we have ammonia, NH3, we have oxygen, and we have sulfur dioxide, which is SO2. Among these compounds, which of them can be collected over water? Don't forget, we said initially that for a gas to be collected over water, it must be insoluble. This is point 1. Point 2, it must be slightly soluble. Hydrogen chloride is highly soluble in water and it will dissolve. For ammonia is also highly soluble and it will do what? It will dissolve. Once a gas is highly soluble, if you cannot collect it over water. If you collect it over water, it will dissolve. Oxygen is slightly soluble. When collected over water. And then don't forget the condition we stated initially says for a gas to be collected over water, it must be insoluble or slightly soluble. Oxygen here is slightly soluble. So oxygen is suitable. For sulfur dioxide is highly soluble. And as such, it will dissolve. So the correct option here is what? Oxygen, which is slightly soluble. Oxygen satisfies this condition. Therefore, the gas that can be collected over water because it is insoluble is what? Oxygen.